Ma'am, I think we can start. Rushali ma'am, are you ready?
Yes, ma'am. We can start now.
Yes, Shivanjali madam, are you there? Yeah. Mute, unmute karo. Yes, okay, start. Sir, with your permission, can we start?
Oh, yes, ma'am.
Yes.
Good afternoon, everyone. I, Assistant Professor Shivanjali Talari, on behalf of Bharat College of Arts and Commerce, welcomes you all to the 6th day of capacity building program on research methodology. Before we start the program, I request you to raise yourself for the national anthem. I request Rishali ma'am.
Yes, ma'am. Yes.
Thank you, Rishali ma'am.
Okay, ma'am.
Our today's topic for the first session is parametric test. Let me introduce today's guest speaker. It's my great pleasure and honor to introduce today's guest, Dr. Atman Shah sir. He is PhD in economics. He is currently working with St. Xavier's College, Ahmedabad as assistant professor. He is also in the board of studies of the economics department. He has more than 7+ years of experience in teaching. He teach economics, SPSS and R. He has published many research papers in national and international conferences. He writes articles for national and regional newspaper, online portals such as the Indian Express, the Pioneer, PCC Gujarati, NewClicks, etc. To help students and researcher, he run a YouTube channel which has more than 15K plus subscriber now. He has uploaded the videos on economics, SPSS, and R Studio. I request I again welcome you, sir, and I request you to start with the today's session.
Thank you very much, ma'am, for your kind introduction, and thanks to Bharat College, Savita ma'am, and principal for providing me this opportunity to interact with the workshop participants. So topics assigned to me are parametric tests and hands-on practice. So in the first half, I'm going to discuss the basics of SPSS, and then we'll do theory and practice together. So I'm not direct jumping into the parametric test. So first we will discuss the basic operations of SPSS, and then we will try to understand the parametric test and how to perform various parametric tests in SPSS and how to interpret the results. So that is the flow of these today's sessions. So let me share my screen. Before we understand the idea of parametric test, or before we start working on SPSS or any other software, we need to understand the nature of the data, whether we have qualitative data or quantitative data. Because the selection of the statistical test, whether you are going to perform parametric test or non-parametric test, that depends on the nature of the data. If you have qualitative data, you cannot perform parametric test, right? So understanding the nature of the data, understanding the structure of the data is very important before we perform the statistical test. So let's understand the nature of the data and try to bifurcate the data into qualitative and quantitative categories. So I'm sharing my screen. Is my screen visible, ma'am?
Yes, sir.
Okay.
Yes.
So data is classified into various levels or scales of measurement. The level of measurement determines how data should be summarized and presented. Right? The selection of the descriptive statistics also depend on the nature of the data. You cannot use arithmetic mean every time. So if you have non-normal data, if you have outliers in the data, you cannot perform, or it is not advisable to perform the arithmetic mean. So scales of measurement refer to ways in which variables or numbers are defined and categorized. And it also indicates the type of statistical analysis that can be performed. So Stephen, in his article, The Theory of Scales of Measurement, defined 4 scales: nominal, ordinal, interval, and ratio. Why we are discussing this? Because the selection of the statistical test, whether you are going to use parametric or non-parametric test, that depends on this, whether you have nominal, ordinal, interval, or ratio scale data. And when you enter the data in the SPSS, you need to tell the SPSS that this is my nominal variable or this is my interval or ratio variable. This includes qualitative and quantitative both. Let's understand the idea of nominal variable. Nominal variable is also known as a categorical variable. Now, nominal variable is used to label the variable without any quantitative value or order. This is very important. Without any quantitative value or order. That means these values do not have any numerical meaning, any intrinsic value. And this data can be placed into categories, but cannot be multiplied, divided, added, or subtracted. So no mathematical operations, no logical operations can be performed on nominal variable. It is example. Suppose you have the data on level of income. And you are bifurcating data into 3 categories: low income, middle income, and high income. Right? Now you assign 1 to low income group, 2 to middle income group, and 3 to high income group. So here order doesn't matter. You can assign 48, 49, and 50. No problem. Assign 48 to low income, 49 to middle income, and 50 to high income group. So therefore, order is not important. These values have, and therefore level of income is our nominal variable. And in this nominal variable, you have these 3 categories or 3 levels or 3 subcategories. Suppose you have nominal variable with only 2 categories. You have nominal variable, but in that nominal variable, you have only 2 categories. Then that nominal variable is known as dichotomous variable. The gender. You assign 1 to male and 2 to female. Again, you can assign any number. I can assign 99 to male and 100 to female, or 40 5 to male and 44 to female. It doesn't matter. Order is not important. But here, gender has only 2 categories. Therefore, gender is dichotomous variable. Suppose in level of income, you have defined only 2 categories. 1 low income and 2 high income. Then level of income will become dichotomous variable. So a nominal variable with only 2 categories is known as dichotomous variable. Second is ordinal variable. Here the order is very important, but the difference between the values is not. Difference is not important. This is used to express the non-mathematical concepts, just as happiness, satisfaction, pain, movie ratings, right? All of us are using Paytm or GPay, any online platform, right? So every time you do the transaction, the company asks you to rate on a scale of 0 to 10. That is ordinal variable because order is important. So 0 represents highly dissatisfied and 10 represents highly satisfied with the service. Here the values can be added or subtracted from. Here is example. One company wants to examine the satisfaction of the consumers of its product. 1 is unhappy, 2 is neutral, and 3 is happy. So here order plays an important role. You cannot interchange the order. But difference can't be measured. Suppose you are choosing 1 and I am choosing 3. That means you are unhappy with the service, with the product. I am happy with the product. But what is the distance between 2? How much more you are unhappy or how much more I am happy than you? That cannot be measured. And therefore, difference between the values is not important in ordinal variable. But order is important. You cannot interchange this. Then we have interval scale data. Interval data is ordinal. It has all the properties of ordinal data, but the difference between 2 values is known. So this is the additional property. In addition to all properties of ordinal variable, here the difference between 2 values is known. And this type of data shows both the order of the variables and the exact difference between the variables. It means that difference has some meaning, but we cannot take the ratio of 2 interval data. Another important property is 0 means variable exists. It means 0 has meaning. 0 does not indicate the absence of the variable. See this example, you will understand the idea of interval scale data. Temperature. The difference between a temperature of 40 degrees and 30 degrees is the same as the difference between 50 and 40. That means difference has some meaning. You can easily say that yes, the difference is 10 degrees Celsius. Right? Another point is 0 degrees Celsius means you have the data. That means 0 has meaning. You have the data points, you have the observations when value is 0. Right? And then we have ratio scale data. Now, ratio data has all the properties of interval scale, but arbitrary 0 has no meaning. That means 0 does not exist. You don't have data points when the value of the variable is 0. For example, 0 weight does not exist. That shows the absence of the variable. Weight cannot be 0. Now, you don't have any data points when weight is 0. But 0 temperature exists. You have the data point. So temperature is interval data. Weight is ratio scale data. So data in the ratio scale can be added, subtracted, divided, and multiplied. All mathematical operations, all logical operations can be performed on ratio scale data. this is the idea of nominal variable, ordinal variable, interval variable, and ratio scale variable. Now, when you enter the data in SPSS, SPSS will give you three options: nominal, ordinal, and scale. SPSS will give you three options: nominal, ordinal, and scale. So this scale includes interval and ratio both. So when you enter the data in SPSS, you need to select whether you have nominal variable, ordinal variable, and if you have interval or ratio variable, you can select scale. Right? Okay, so now I'm sharing my SPSS screen. Any doubts in scales of measurement, because it is very important? Anyone? You can also write in the chat box. Okay. So open your SPSS file, blank SPSS file, and then we will work on the file shared with you. Now, when you open the SPSS, the screen is very similar to Excel sheet. Right? You can see the boxes, you have rows and columns. But here we need to define the variable. In Excel, we don't define the variable. We directly enter the data. But in SPSS or in any other software, we need to tell the SPSS the structure of the variable and nature of the variable. Now, suppose you have the data on income. So income can be used in many ways. Suppose you have the categories, the way we have discussed: low income, middle income, and high income. So then level of income becomes nominal variable. But suppose you have the absolute data: 10,000, 15,000, 25,000, 50,000. Then level of income becomes quantitative data, ratio scale data. Right? Or continuous data. So it is upon the researcher how to use the available variable. And that depends on your objective, that depends on your hypothesis, whether you want to treat level of income as nominal variable or quantitative variable. Right? So here you have two views: data view and variable view. See left down corner. Data view and variable view. And when you open the SPSS, you also have the output window. So SPSS has these three windows: data view, variable view, and output window. You need to save data file and output separately. I'm repeating myself, and this is very important. You need to save your SPSS data file and SPSS output file separately. Right? And the extensions are also different. So let's understand the variable view. In variable view, we are going to define the variable. Right? That is the idea of variable view. So let's define first variable: roll number of students.
Excuse me, sir.
Yes.
Sir, have you shared SPSS software on
Yes.
screen?
Is it
So
not
we are
visible?
not able to. No,
Oh,
no,
sorry,
sir.
sorry.
Yes, sir. Now we are able.
Okay. So let me repeat. See your SPSS screen. On left bottom corner, you have data view and variable view. Right? And if you look at the Screen, it is very similar to Excel sheet. You have icons, you have title bar, menu bar, right? This is the output window of SPSS. So as I said, you need to save these two files separately, right? You need to save the data file and output file separately. Now let's see the data file. Go to variable view. In variable view, we define the variable. So let's understand each column first. First column is name. So here you need to write the name of the variable. Now you cannot use space and you cannot start name with the number. So suppose I'm writing 4ABC and enter. Shows an error. Variable name contains an illegal first character. That means I cannot start name with number. Let me use space ABC space EFG. Enter. Again, variable name contains an illegal character. Right? So suppose you want to use the space, you can use underscore roll number and space enter. All other columns will be filled with default values. Let's understand second column, that is type. So this shows the type of the variable. You have numeric variable, you have string variable. Suppose you are entering the name of the students. Suppose I'm writing Atman Shah. So that is string variable, it is not numeric. Right? Then we have width. Now, what do we mean by width here? It shows the number of characters you want to see in the data view. So maximum this variable will show 8 characters in data view. So suppose you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in data view, you will see only 1 to 8 because width is 8. Then your decimal points. How many decimal points you want? So in roll number, we don't want any decimal points. In label, you can actually write the name of the variable. So I can write roll number of students. And this label will appear in the output. Suppose you use this variable, then in output, you can see the label, that is roll number of students instead of roll underscore number. So we are generating the table. So in that table, if you are using this variable, you will see roll number of students and not roll underscore number. Values, this column is used to give the labels. Suppose you have the data on gender. So you can assign 1 to male and 2 to female. We'll discuss this later. Missing, suppose you have any missing values in your data set, you can use this column. Now this columns actually shows the width of the column. Alignment, right, left, center. Now in measure, you need to select either scale, ordinal or nominal. So as I said, you have 3 options, nominal, ordinal and scale. Now roll number is nominal variable. We are randomly assigning numbers to students. Order doesn't matter. Now you can assign roll number 10 to roll number 1. Does not make any difference. Does not make any difference to a variable. And therefore roll number is our nominal variable. So we are telling the SPSS that treat this variable as nominal. And here last column shows the role of the variable. What role this variable is going to play in the data analysis, whether it is target variable, whether you want to split this variable, but this is used when you are performing regression analysis or multiple linear regression analysis. So you don't need to change anything. Go with the default selection, that is input. Right? Second, gender. Click on gender, sorry, gender and press enter. Again, we don't want any decimal points. Now go to values column and click on three dots. You will see this dialog box on your screen. Now we are defining the categories. So in gender, we have two categories, male and female. So write one in value box and male in label and then add. So we are telling SPSS that whenever I write one in the gender column, treat it as male and two is female. You can see one is equal to male, two is equal to female. Don't forget to press OK. Measure is again nominal. And then last is suppose marks. So in label, I can write full name marks out of 100. We don't want decimal points. Now this marks is quantitative variable. So you need to select scale. Right? And then go to data view. See, these three variables are created. Roll number, gender, and marks. If you put your cursor here on roll number, you can see the entire name, label, and type. If you go to gender, you can also see name, gender, type, numeric, measure, nominal. Marks, label is marks out of 100, type is numeric, measurement is scale. Now you can enter the data. So suppose I'm entering data 1, 2, 4, 5, 6, 7, 8, 9, and 10. Gender. Instead of writing male and female, you just need to press 1 and 2. 1 male, 2 female. Right here you have this icon, see 1 to A icon, value labels icon. So suppose you don't want to see male and female and you want to you are comfortable with 1 and 2, then you can click here. So instead of labels, instead of male and female, you can see 1, 2 or the assigned numbers. And I'm entering marks randomly. 67. So now our data set is ready. So this is how we enter the data in SPSS. Suppose I directly add data here without defining the variable. See what will happen. I'm writing 57. Automatically this variable is created, VAR00001. Right, go to variable view. You have this fourth variable. Since you have not given the name, the automatic name is VAR00001. So you can change the name. Suppose I'm writing internal marks, INT. Internal marks. Right? And here you can select scale. And then go to data view. Instead of VAR, now it is INT. Okay. Any doubts in this? Anyone? Okay. So open the SPSS file, SPSS practice file, November 2022. We are going to work on this data set. Let's wait for 1-2 minutes so you can see the data. Okay. So let's understand the data set first. So my first variable is students. Right? This variable shows the roll number of students and it is nominal variable. Second is gender. So in gender, 1 is assigned to male and 2 is assigned to female. Third variable is stay. Now in stay variable, I have 3 categories. Whether students are staying at hostel, PG or home. So 1 is assigned to hostel, 2 is assigned to PG and 3 is assigned to home. So we have 3 categories and it's a nominal variable. Fourth category is faculty. So in faculty, I have 4 categories. 1 is assigned to arts, 2 is assigned to commerce, 3 is assigned to science, and 4 is assigned to management. So faculty is also our nominal variable. Then we have internal marks, INT. It is quantitative variable, so I have selected scale. Sixth variable is external marks, again quantitative variable, so scale is selected. Seventh is external marks 1, that shows the marks after remedial classes. You can see in labels, external marks after remedial classes. Right, and last is reading hours per day. So how many hours students are reading per day? That is the variable and is again scale variable. Now see the data view. I have data of 60 students. This is hypothetical data. Then we have gender, in which we have 2 categories, 1, 2. In stay, we have 3 categories, 1, 2, and 3. Hostel, PG, and home. And in faculty, we have 4 categories, arts, commerce, science, and management. So you can see 1, 2, 3, and 4. And then we have data on internal, external marks after remedial classes, and reading hours per day. Right? Okay. Let's understand the some basic operations, some basic commands which are useful in SPSS. Now, suppose you want to compute a new variable using the existing variables. So suppose I want to compute a new variable using internal marks and external marks. Right? I want to calculate total marks out of 100. So internal marks, are out of 30, external marks out of 70. Now I want to calculate total marks. That means you want to compute a new variable by using existing variables. So if you go to transform, in transform you have the option of compute variable. Go to transform, select compute variable. In target variable, write the name. So it is total marks. Remember, when you write the name, space is not allowed and you cannot start the variable name with number. Now, what is our numeric expression? It is internal marks plus external marks. So select internal marks. Move it to the numeric expression. Select plus external marks. So this is our numeric expression. So we are informing the SPSS that calculate or compute a new variable by using this numeric expression, and name of this variable is total. And simply click on OK. Now see, this total column is calculated. And if you go to the variable view, you can see this new variable total. Right? We don't want any decimal points, so I'm selecting 0. Right? So you have total marks here. Now suppose we want to give ranks. So again, go to transform. In transform, you have the option of rank cases. Select rank cases. Now we want to give ranks by total marks. So select total and move it to the variable box. Because we want to assign rank as per total marks. Now here see, assign rank 1 to smallest value or largest value. By default, smallest value is selected. So we need to change this because we want to assign the first rank to the largest value in this total variable. So select largest value and simply click on OK. See your data file, another column R total is created. 2 decimal points. Now, why I'm using 2 decimal points? In statistics, you need to understand the ranking process, how we give rank. So let's arrange this in the chronological order and then understand. Right click on it. Select sort ascending. Now here you see we have the tie on 3rd and 4th rank. So what statistic does? We take the average. Statistic takes the average of these 2 ranks. So we have rank, we have tie on rank 3 and rank 4. So 3 plus 4, that is 7, divided by 2, that is 3.5, 3.5. And then it directly starts with 5. So again, we have these 2 ties on 5th and 6th position. I think someone's mic is on. Yeah, thank you. So the 5th and 6th position. So 5 plus 6, 11 divided by 2. Here 5.0, 5.0, and then we start from 7. So this is how we give rank in statistics, because it is very useful, because we use rank when we compute the rank correlation developed by Spearman. Right? So when you do manually, you need to assign rank in this manner. Right? Okay. So go to students, right click on it and sort ascending. So we'll get the original data set. Now, suppose you want to identify the duplicate cases, whether you have any duplicate cases or not. So intentionally, I am creating the duplicate case. 5 female home management 15 25 38 2 56. I'm removing this R total column. So here we have these 2 duplicate cases. Sorry, 40. Right? Before you perform anything, you need to remove the duplicate cases. So we need to identify whether we have any duplicate cases in our data set or not. So go to data. In data, we have the option of identify duplicate cases. So select identify duplicate cases. Select all and move them to the define matching cases by. Now see this variables to create box. Indicator of primary case, 1 is unique or primary and 0 is duplicate. Now simply click on OK and see your data sheet. See here we have this primary list column and you have these duplicate cases on the top of the data set. Right? So 1 is duplicate and another is primary. So if you see this, 0 is written. So 0 is duplicate, 1 is primary. So you need to remove this. So simply right click on this, clear, and then again arrange the data set in the ascending or descending order. So this is how you can identify the duplicate case. Remove this. Now suppose you want to select cases, you want to work on the students who have scored more than 40 marks in external examination. You want to analyze the data of students who have scored more than 40 marks in external examination. So you want to select that data. Out of this available data, you want the students who have scored more than 40. So for that, we have the option of select cases. So go to data. Here we have the option of select cases. So click on it. By default, all cases are selected. So click on if condition is satisfied. If. So what is the condition? External marks is higher than 40. So we are telling the SPSS that select the cases using this condition. And simply click on continue, click on OK. So you have this column, whether your variable is selected or not, or from this also you can identify. This dash line means this observation is not selected. See, because they have scored more than less than 40 marks in external examination. This is the variable. Right now you perform any statistical test, any command in SPSS, you will get the data or you will get the result for the selected data set only and not for the entire data set. Right? So make sure you remove this or you reset the setting. Otherwise, you will get the answer for selected data sets only. So again, go to data, select cases, select all cases and OK. See, these dash lines are gone. And then you can remove this variable. So that is the idea of selecting cases. Now you can use any numeric expression that depends on your requirement. Okay. Then we have some other basic operations. Suppose using sets. I don't want all variables on my screen. I want to use students, gender, internal marks and external marks only. Suppose you have large data set. You have 40, 50 variables. So it becomes difficult to scroll up and down or scroll right and left. So you want to use this subset of your data. So I want to create a subset of these 4 variables: students, gender, internal marks and external marks. So go to utilities. See, here you have the option of utilities. In utilities, you have the option of data variable sets. Now give names. I'm writing Bharat College. Want to use roll number, gender, internal marks and external marks. So select these 4 variables and move them to the variables in set and click on add set. So you see this Bharat College subset is created. And if you select this Bharat College, you can see the list of variables. Now close it. Again, go to utilities. Here you have the option of use variable sets. And then select Bharat College only. Okay. So now you have only these 4 variables. All of the variables are there. They are not gone. They are not deleted. But right now, I don't want them on my screen. I don't want to use them. I want these 4 variables only. Suppose you want your entire data back, go to utilities, use variable set and select all variables. And simply click on OK. Then you have all variables. Right? So you can create as many subsets as you want. It is very useful when you have the large data set. Right? Then we have a split file option. Suppose you want to split the file. I want to split my file gender wise. So I want male students first and female students, or I want the data on stay wise, hostel students, PG students, and home students. Or faculty wise, arts, science, commerce, and management. That means we want to split the file using the available nominal variable. So there are 2 ways. Here you have the icon, split file icon. See this. So select this split file. By default, analyze all cases and do not create groups is selected. So instead of that, select organize output by groups. And select gender and move it to the groups based on. So that means we want to split our file gender wise. And in gender, we have 2 categories, male and female. So this file will be splitted into 2 parts, male and female. And simply click on OK. Now see data file. You have male students first and then female students. Why we have male students first? Because 1 is assigned to male and 2 is assigned to female. If you assign 1 to female and 2 to male, then we have female students first and then male students. Right? Now again, once your file is splitted, you will get the output male wise and female wise separately, and you are not going to get the output for the entire data set. So make sure you reset the setting. Again, go to split file, analyze all group, go to split file, and let's see what happens if we select faculty. Okay. Sorry. Organize output faculty wise. See faculty column. First we have arts students, then commerce, then science, and then management. So now if you perform any statistical test, you will get the result for arts students, commerce students, science students, and management students separately. You will not get the result for the entire data set. Right? So split file is used to get the result category wise. Suppose you want the descriptive statistics category wise. Mean marks of art students, science students, commerce students, and management students. So you can use split file command. Okay. So go to split file again, select analyze all cases, create, okay. And then again rearrange. So this is split file. Okay, so now let's discuss descriptive statistics and frequency distribution table. It is very important to use the appropriate descriptive statistics. So you have measures of central tendency and measures of dispersion. Now, which measure we are going to use, that depends on the structure of the data. So for nominal and ordinal data, there is no need to perform the descriptive statistics. And there is no reason to find the mean of gender, stay, or faculty variable. It doesn't mean anything. Right? So when we have nominal data, we normally use frequency distribution. That how many male students are there, how many female students are there, how many students are staying in hostel, PG, and home, how many students are from arts, commerce, science, and management faculty. So that is the idea of frequency or frequency distribution table. So go to analyze. In analyze, we have the option of descriptive statistics, and in descriptive statistics, we have the option of frequencies. Right? So select frequencies. Now suppose I want stay-wise frequencies. You simply click on OK. See the output window. Now, as I said, the result will be generated in output window, and you need to save this window separately. So this is the result. We have 19 students from hostel, 22 students from PG, and 19 students from home. You also have the percentage. See. Out of total students, 31.7% from hostel, 36.7% from PG, and 31.7% from home. Again, go to the same dialog box. So to use the same command, here we have the option of recall recently used dialogues. You don't need to go to analyze and frequencies every time. Simply click on this. You can see the recently used dialog box. So click on frequencies and go to charts. See, here we have charts tab. Select bar chart. Now instead of frequencies, select percentage. So it will help you to generate the bar chart of the frequencies of stay variable. So click on continue, click on OK. It will take 10-20 seconds to generate the graph. See here. Hostel, PG, and home. I will double click on it. On the chart editor window will open. And here we have the option of show data labels. Select this. Close it. And you can see the data labels at 31.67% in hostel, 36.67 from PG, again 31.67 from home. So simply close it. And you can see the data labels. Right? Excuse me. Okay. Again, go to frequencies. Select all three nominal variables. Go to charts. Instead of bar chart, select pie charts. Continue. Okay. So this is state-wise frequency distribution table. This is gender-wise. So we have 30 male students and 30 female students. Faculty-wise, 12 from arts, 19 from commerce, 18 from science, and 11 from management. This is pie chart for state, gender, and faculty. So okay, you double click on it. Chart editor window will open. Select chart labels. And close it. So this is the use of frequency distribution table, or you can also generate the chart. Now, whether which chart we are going to use, that also depends on the structure of the data. For nominal data, you need to use pie chart and bar chart, right? Because that shows the frequencies. Each slice of this pie chart shows the frequencies. That 18.33% students are from management, because orange color represents the management. Similarly, bar chart, each bar represents the frequency of a particular category. So bar chart and pie charts are used when we have the nominal variable to represent the category of various nominal variables. That how many frequencies are there, how many observations are there in each and every category of our nominal variable. Again, go to data view. Now let's understand the descriptive statistics, right? Because when we perform parametric test, the parametric test generates the descriptive statistics. So how to find descriptive statistics? Suppose I want the descriptive statistics for internal marks. So go to analyze, descriptive statistics. Here we have the option of descriptives. There are multiple ways to find descriptive statistics in SPSS. So let's explore each and every method. So first go to analyze. In analyze, you have the option of descriptive statistics, and in descriptive statistics, select descriptives. Now we want descriptive statistics for internal marks. So move internal marks to the variable box and click on options. So here you have mean, sum, variance, range, standard error of mean, kurtosis, skewness. Select all the available options. Continue. Okay. So see the result here. First is range. First is n. N is the number of observations. So we have 60 observations. Then range. Range is the difference between maximum and minimum value. So you see here, maximum value is 28, minimum is 6. So 28 minus 6 is 22. Then we have summation, that is sigma xi. So it is 1068 divided by 60, that is 17.80. This is mean. Then we have standard deviation. Square of standard deviation is variance. And then we have skewness and kurtosis, which are used to identify whether we have normally distributed data or not. Right? Now go to descriptives again and select all the remaining variables. You can find the descriptive statistics for all variables simultaneously. So click on OK. And then you have the descriptive statistics for all variables in a single table. Right? Now let's see what happens if our data file is splitted. So go to data view and split this file gender wise. And now file is splitted gender wise, and then use descriptive statistics for internal marks only. Okay. See, you have descriptive statistics for male and female separately, and you don't have the descriptive statistics for the entire data set.
Sir, one question here.
Yes.
You have created both these descriptive statistics for this, right? Male and female. Now, mean for male is something 17.73 and the female is 17.87. What does indicate exactly? Which one is better and something we can assume from this?
Let me clarify this. With the use of descriptive statistics, you cannot conclude anything. For that, you need to perform the statistical test. Suppose you are interested to know whether males are scoring higher than female or female are scoring higher than male. For that, you need to use the independent t-test.
Yes,
Just
that is
by,
right.
yeah, so just by observing the descriptive statistics, you cannot conclude, right, whether you have the significant difference or not. And that is the idea of hypothesis testing.
Fine, sir. Thank you so much.
Yeah. Right now, suppose let's split this file gender and faculty wise both. So click on OK. First, see your data file. You have male students, male arts students, then male commerce students, then male science students, and male management students. Then female arts students, female commerce students, female science students, and female management students. Now, this data file is splitted gender and faculty wise simultaneously. Now, see the result of descriptive statistics. See here, gender male, faculty arts. So male arts students, descriptive statistics, male commerce students, male science students, male management students. Then we have female arts, female commerce, female science, and female management. Suppose I split stay wise. So gender, faculty, and stay wise simultaneously. Simply click on OK and then run descriptive statistics. See result. Gender, male. Gender, male, faculty, arts, hostel. Then gender, male, faculty, arts, PG. It completely depends on you, which data you want, how you want to represent your data, how you want to use the descriptive statistics. Right? So let me reset the file again, analyze all cases. okay, and now you perform descriptive statistics, you will get the result for all the observations of the entire data set. Right? Okay. Another way to perform descriptive statistics is, suppose you want the descriptive statistics of external marks. Let me rearrange this first. External marks. So select external marks column, and here you have the option of this new, which says run descriptive statistics. I don't know whether you have this option in the older version or not, but I am using 25th version of SPSS, and I think if you are using the free trial version, you have the 27th or 28th version. So select this icon and you simply have this data: mean, median, standard deviation, range, minimum and maximum. So this will provide the data for these measures only. Okay. Again, go to analyze, descriptive statistics, and select explore. Another method to find, or another way to find descriptive statistics. So you want to find the descriptive statistics for internal marks, so select internal marks dependent list. And now we want again gender wise internal marks. So select gender in the factor list. Right? Click on statistics. Sorry, click on plots. From here you can see the you can check the normality assumption, but that we will discuss in the second half or tomorrow. So how to check the normality assumption in SPSS. So I'm not using it right now. Now whether you want statistics and plots both, so I just want statistics and not the plots. So click OK. And now you see the result. Result of male students and result of female students. So you have mean, median, variance, standard deviation, minimum, maximum, range, interquartile range, skewness, kurtosis, everything. Suppose you select faculty, then you have faculty wise bifurcation: art students, commerce students, science students, and management students. Suppose you select all the available nominal variables. So arts, I mean faculty wise, then we have gender wise, and then we have stay wise. Right? So this is how we use or we compute descriptive statistics in SPSS. Okay. Another important command or another important tool that we normally use in research is cross tabulation. How many male students are there in arts faculty? I want that table. How many female students are there in commerce? So we want the cross tabulation for gender and faculty. So again, go to analyze, descriptive statistics, cross tabs. Go to analyze, descriptive statistics, and cross tabs. So select cross tabs. Now in row, suppose I want gender, and in column I want faculty. Now you can interchange this and simply click on OK. See this cross tab. So 6 male students are in arts, 9 in commerce, 12 in science, and 3 in management. In total, we have 30 male students. Then we have 6 female students in arts, 10 in commerce, 6 in science, and 8 in management. right? Now, suppose you want percentage, that how many students are there in arts, commerce, and science and management. So go to cross tab again, select cells, click on cells button. And you want percentage row wise, column wise, and total. Select these three. In percentages, select row wise, column wise, and total. And click on continue. Now see this table and let's understand this. First, we have percentage within gender. What does that mean? Total, we have 30 male students. Out of this 30, 20% are in arts, 30% are in commerce, 40% are in science, and 10% are in management. Right? Then we have percentage within faculty. So total, we have 12 students in arts. Out of these 12 students, 50% are male and 50% are female. See 50-50. We have 6 students in 6 male students and 6 female students. Right? See commerce. Percentage within gender, 30%. Percentage within faculty. So 30% commerce students are male, and within faculty 47.4% are male and 52.6% are female. Right, so you can use this descriptive, you can use cross tabulation to know the interaction between two variables. Now we can also add layer. Go to cross tab and add layer of stay. Now I'm untick this percentages options. See, now we have interaction of all 3 nominal variables. See, here we have stay column, hostel, PG, home. Then we have gender, and then we have arts. So this 3 means male arts students who are staying in hostel. And if you select percentages, you can have this table. And you can also change the row and column. So instead of gender, I'm selecting stay here and move gender to the layer box. Click OK. Now we have gender here, male and female, and then we have stay variable. So again, that depends on you how you want to represent your data in the thesis or dissertation. Right? Yes. Any doubts? Anyone? Let me check the chat box. What is the role of standard deviation? Okay, so standard deviation is the measure of dispersion, right? How far your data points from the mean value. That is the idea of standard deviation. Standard deviation and variance both. I hope it is clear. Rahul.
Yes, sir.
Yeah. Then we have from Bhavi, Dr. Bhavika Thakur. What about missing value in the data set? So suppose you have the missing value, we need to identify the missing value. You can replace the missing value. There are various methods. You can replace the missing value by mean method, median method, or you can also remove the data. Remove the data point, that particular data point. Yes, any other questions in SPSS or in theory? Anyone?
I think basics are clear, sir. We can take break if you want.
Yeah, sure.
Since the theory part, the basic part is over, na?
Yes, now we'll move to parametric test.
Okay, then we can take break of 5-10 minutes, as you
Yeah,
say.
yes.
We'll not leave the meeting. We are in the meeting. At whatever point you join, we'll start again.
Okay. Thank you, ma'am.
Okay. Thank you, sir.
Shall we start, ma'am?
Yes, sir, we should start.
Okay, okay. Let me share my screen. Okay, let's understand the parametric tests and how to perform them in the SPSS. The difference between parametric test and non-parametric test is based on two things: type of data, whether you have quantitative or qualitative data. We can use parametric test, and another is normality, assumption of normality. So if our population follows normal distribution, we can use parametric test. So when you have the data, you need to check these two possibilities. First, check whether you have the quantitative data or not. If your data is qualitative, then there is no need to check the normality assumption. You cannot perform parametric test on qualitative data, right? So first check whether you have the quantitative data, and then check whether the quantitative data follows normal distribution or not. So if it follows normal distribution, that means we don't have outliers. If you have outliers in your data might be either positively skewed or negatively skewed. In that case, you should use non-parametric tests. So again, check these two possibilities: type of data and normality. Now all t-tests are parametric tests. Independent t-test, one sample t-test, and paired samples t-test. All are parametric tests. So let's understand all t-tests. First, we are going to understand the idea of t-test, under which conditions you can use t-test. So assumptions, meaning of each t-test, how to formulate hypothesis, what are the steps involved in performing the t-test, and then interpretation. Now, t-statistic was introduced in 1908 by William Seeley Gossett. He published his work under the pseudonym of Student. Therefore, it is known as Student t-test. If you refer to some books, it is written Student's t-test. So we have three types: one sample t-test, paired samples t-test, and independent samples t-test. Now, what are the assumptions? And these assumptions are common for all t-tests. So first, the sample should be collected randomly. So we have random selection of the sample. Now, when we say random selection, it means each and every observation has the equal probability of being selected in the sample. That is the idea of random selection. Second, the selection of observations should be independent of each other. That means my selection does not affect the probability of being selected of other observations. The variance of the population should be unknown. The data must be continuous, interval or ratio, and this continuous data must be normally distributed. And therefore, it's a parametric test. What is one sample t-test? As name suggests, we have only one sample here. Now, it is used to compare the sample mean with population mean or a given value. When we use one sample t-test, it is used to compare the sample mean with the given population mean or a given value. So it is used to determine whether the sample is generated from a population having a specific mean. And it works only with one mean score. So that is why it is known as one sample t-test. The name itself suggests the use of the statistical test. Now see the procedure. How do we conduct one sample t-test, or what we do in one sample t-test? So first we randomly collect the data. So that is random collection of sample. Compute sample mean, that is x bar. And then compare this sample mean, that is x bar, with given population mean mu. And check whether we have the statistically significant difference or not between sample mean and population mean. Right? See these examples. We could use one sample t-test to examine whether the consumption expenditure of male is higher than the national average. So we can randomly collect the data on consumption expenditure of male. Then we can compute the mean, that is x bar. You randomly collect the data of the consumption expenditure of male participants. Then you compute the mean consumption expenditure, that is our x bar, and then compare this with national average. Now national average is given value, right? And check whether we have the significant difference or not. Second, test whether the depression level of the participants is statistically significantly different from the normal depression level. Now this normal depression level is given. Right? And then you collect the data on depression level of the participants. You find the mean, so that is x bar. Compare this x bar with the normal depression level and check whether these two are statistically significantly different from each other or not. But to examine whether energy drink provides you the advertised level of protein. Now this advertised level of protein is given value. Right? And then we can collect the data on energy drink, whether the energy drink provides the advertised level of protein or not. So we can compute x bar here. Fourth, to test whether a vehicle or car provides you the advertised level of mileage. So advertised level of mileage is given value. Right? And then we can find the x bar. You can take the data of 10 or 15 or 70 people. So these are some examples in which we could use one sample t-test. I have tried to take the examples from various fields, not from economics only, so that you can easily understand the use of the statistical test. Once you identify that which statistical test is used, then it is very easy to perform it in the software and interpret it. The main part is selection of the statistical test. Now, how to formulate hypothesis? What is null hypothesis? Null hypothesis says that there is no significant difference between population mean and sample mean. That means both are equal. So that is mu is equal to x bar. This is our null hypothesis for one sample t-test. Alternative hypothesis, significant difference between population mean and sample mean. That means mu is not equal to x bar. Right? This is how we formulate the hypothesis. Normally, null hypothesis says that there is no difference. An alternative hypothesis says that we have the significant difference. So here we are comparing sample mean with population mean. So in null hypothesis, we are saying that no, both are equal. There is no significant difference. In an alternative hypothesis, we are saying that we have the significant difference between population and sample mean. Right? What are the steps? So first, random selection of the sample, step 1. Step 2, check the normality assumption. If it is not normally distributed, you cannot use one sample t-test. Define null and alternative hypothesis. Specify the level of significance, that is alpha. Now, alpha is our type 1 error. Right? What is alpha or what is type 1 error? It is the probability of rejecting true null hypothesis. Probability of rejecting true H0. Since we are rejecting the H0, therefore we are committing an error. So this error is known as type 1 error or alpha. That is level of significance. Now calculate the sample statistic manually, or you can perform the test in software, that is step 5, and then you interpret the result, and this is the decision rule. How to decide whether you are going to reject the null hypothesis or not. So if your p-value is less than alpha, you reject null hypothesis. And if your p-value is greater than alpha, we fail to reject the null hypothesis. Right, see, normally we don't use except word here. We are not accepting alternative hypothesis, but we do not have enough evidence to reject the claim. And therefore, we are using the term reject and fail to reject or do not reject. Right? This decision rule remains same for all statistical tests. P-value less than alpha, reject. P-value greater than alpha, we fail to reject. Now, let's open the data file. Sorry. Now, suppose we want to know whether this data is generated from the population having the mean internal marks of 17, 17, right? First, we need to check the normality assumption. We need to check whether internal marks are normally distributed or not. So go to Analyze, Descriptive Statistics, Explore. Select internal marks. In the dependent list, go to Plots. I mean, plots, here we have the option of normality plots with tests. And select histogram, untick, stem, and leaf. Simply click on continue, click OK, and then check your output window. See, here you have this result, taste of normality. So we have two tests, Kolmogorov-Smirnov test and Shapiro-Wilk test. Now, what is the null hypothesis in this case? The null hypothesis says that data is not significantly different from normal distribution. So that is, data is normally distributed. Alternative hypothesis, not normally distributed. Right? Now you see SIG value. This is our P value for both tests. Now this P value is greater than alpha. See our decision rule. P value greater than alpha, we fail to reject the null hypothesis. So since P value is greater than alpha, here we fail to reject H naught. That means the internal marks are normally distributed. So we can use parametric test on internal marks. And now you can use any parametric test you want. Right? Because internal marks is quantitative data and it is normally distributed. Suppose you are working on gender. Now there is no need to check the normality assumption for gender because gender is nominal data. Right? Okay, now see a histogram. Double click on histogram. We can fit the curve. See here you have this option. Show distribution curve. That will help you to visualize whether you have the normally distributed data or not. So click on this. You can see a normally distributed curve. Right? There are other plots also, QQ plot. We have also box diagram. So now internal marks are normally distributed. Now we are interested to know whether this sample is generated from the population having mean internal marks of 17. So 17 is our given value. So go to analyze, compare means one sample t-test. Right? Because we have only one sample, internal marks. We want to compare the sample mean with our given population mean, that is 70. To check whether we have the significant difference or not. So what is our null hypothesis? This sample is generated from the population having mean internal marks of 70. So sample mean and population
Excuse me, sir.
mean are equal. Yes.
What is the value of 70? 70 is the mean of the internal marks?
Yes, that is given. Suppose you have the data, the college provides you the data that mean internal marks is 70.
Okay.
Right, so it is given.
Okay.
And for example, in board exams, you have the overall result of 75%. So that is
Yes,
given
sir.
value. Now you compare whether a particular school or a school in the rural area is taken from this population or not. The sample of this school is taken from this population or not.
Okay.
Right?
Yes, sir. Yes, sir.
Okay, so go to one sample t-test, click on it. Now what is our test variable? Our test variable is internal marks. So select internal marks and move it to the test variable box. What is test value? Test value is the given value, that is 17. Right? Click on options. Now see, by default, the confidence interval percentage is 95. That means our level of significance, that is alpha, is 0.05. If you write 99, then alpha becomes 0.01. If you write 90, then alpha becomes 0.10. right? So I am continuing with the default selection. Our level of significance, that is alpha, is 0.05, and we compare this alpha with our p value. So click on continue and simply click on OK. So here you have these two tables. This is first table that shows the descriptive statistics. N is the sample size, that is 60. This mean is X bar, sample mean, 17.80. This is standard deviation, 5.342. And then we have standard error of mean. This table shows the result of one sample t-test. Now what is t-ratio? It is 1.160. That is t calculated or t statistic. Degree of freedom is 59. So degree of freedom is n minus 1. So n is 60. 60 minus 1 is 59. Then we have mean difference. What is mean difference? It is mu minus x bar or x bar minus mu. So our x bar is 17.80. X bar is 17.80 and mu is 17, and therefore difference is 0.8. Right? Now you see the SIG value here, 0.251. Now this SIG value or P value is greater than alpha. That means we fail to reject H0. Since we fail to reject H0, we can conclude that this sample is generated from the population having the mean internal marks of 17, because these two are not significantly different from each other. See, as I said, this is the idea of hypothesis testing. Mathematically, X bar and mu are different. See, 17.80 is mathematically different from 17. But in hypothesis testing, what we are saying that whether this difference of 0.80, see here mean difference, whether this difference of 0.80 is statistically significant or not. Right? So someone asked the question that how to interpret the mean marks of male and female students. So mathematically both are different, but whether this difference is statistically significant or not. To check the statistical significance, we need to perform the hypothesis. And after performing hypothesis, if you find the particular test statistic significant, you can conclude that yes, we have the difference. Right? Let's see what happens. Suppose this sample is generated from the internal marks from the population having the internal marks of 27, not 17. So go to one sample t-test dialog box and instead of 17 now write 27. Click on OK and then see the result. First table remains the same because sample is same. So n is 16, mean is 17.80, standard deviation is 5.34, and standard error is 0.690. Now see t ratio or t statistic, it is minus 13.340. Degree of freedom remains same because it is n minus 1. See mean difference, minus 9.20. So it is 17.80 minus 27. Right? And our SIG value is 0.000. So this SIG value P is less than alpha, and therefore we reject H0. Right? And when we reject the H0, we are concluding that this sample is not generated from the population having the mean internal marks of 27. So X bar is not equal to mu. Right? Okay, let's see whether you will find the statistically significant difference in external marks or not. Try to solve this question, whether the sample is generated from the population having the mean external marks of 58. Mean external marks of 58 external marks. You can write your answer in the chat box. Then we are doing hands-on, right? So I am giving them questions. Or should I continue to teach? You can write your answer in the chat box, and let's see whether the sample is generated from the population having the mean in the external marks of 58. Use this file only. SPSS practice file November 2022. SIG 0.000 reject null hypothesis. Okay, let's check. Do one sample t-test instead of internal. Select external marks. 57. Click OK. Perfect. SIG value is 0.000. So we reject H0. Right? Okay. Any doubts in one sample t-test? Anyone? So let's move to paired samples t-test. What is paired samples t-test? Assumptions are same. We need random selection of the sample. The data must be continuous, normally distributed. Observations are independent. Now it is used to compare the means of two paired groups on the same continuous variable. So here we have two paired groups. These two groups are correlated with each other. When we say paired groups, we are saying that these two groups are correlated with each other and not mutually exclusive groups. It is also known as dependent samples t-test. See the procedure. Or what do we mean by paired group? So here we have between two time points, pre and post, before and after, between two conditions or measurements, or between a matched pair. Suppose you are collecting the data from husband and wife, so they cannot be treated as independent groups. Or twins, you are collecting the data from twins. Right, so it's a matched pair. They are correlated with each other. What is the procedure? First, random collection of sample. Compute sample mean for both groups, x1 bar and x2 bar. So here these two groups are paired groups. Then compare or check whether we have the significant difference between these two groups or not. Right? See the examples. First, examine the effect of a training program on the productivity of the employees. So here we have two time points. We collect the data before the training program and after the training program of the same employees. Right? And therefore they are correlated. So you collect my data before the training program, data on productivity before the training program and after the training program. So observation remains the same, but time points are different. Right? Suppose you are collecting, you are interested to know the effect of remedial classes on the result of students. So collect the data before the remedial classes and after the remedial classes from the same students, right? To check the effectiveness of the remedial classes. So again, we have two different time points. Second, examine the effect of two different diet plans on weight reduction. So here we have two conditions or two different treatments. Examine the effect of aerobic exercises on the fitness of the patients. Again, two time points, before and after exercise. Examine the response time of patients on two different drugs, two conditions. Examine whether employees have higher salaries after 10 years than they had after 5 years of joining. Two different time points. Right? Examine the effect of advertisement on the sales of the product. Before the advertisement, after the advertisement. So these are some examples of paired samples t-test. So here we either have two different time points or two conditions. Right? We can also have a matched pair, husband and wife, twins. Now, how to formulate hypothesis? The null hypothesis says that no significant difference in mean of two paired groups. That is mu1 is equal to mu2. Now, you need to understand that hypothesis is about the population and not about the sample. Right? And therefore, we are using mu1 and mu2 and not x1 bar and x2 bar. We always analyze the sample, but we are making the conclusions for the population by using the sample data or by analyzing the sample data. So null and alternative hypothesis are always about the population parameters and not sample statistic. What is alternative hypothesis here? Significant difference in mean of two paired groups. So mu1 is not equal to mu2. So null hypothesis says that both are equal. Alternative hypothesis says that both are not equal, and here these groups are paired or correlated. Right? Now see the steps involved in performing paired t-test. So first is random selection of sample. Check normality assumption. We have already checked. Internal marks are normally distributed. Define null and alternative hypothesis. Specify level of significance. Fifth, calculate sample statistic or perform test in software, and then conclusion. So if p-value is less than alpha, we fail to reject the null hypothesis. Sorry, if p-value is less than alpha, we reject the null hypothesis. And if p-value is greater than alpha, we fail to reject the null hypothesis. Let's open our SPSS data file. The same data file, SPSS practice file, November 2022. Now, here we have the data on external marks and external marks after remedial classes. And we are interested to know the effectiveness of remedial classes on the result of students. So we are collecting the data from the same students at two different time points. See this row. You are collecting the data from student 1 before remedial classes and after remedial classes. Right? That is EXT and EXT1. And therefore we have matched pair. Right? You cannot treat these two groups independently. They are correlated with each other because one data point also affects the another data point. So how to perform this? Now, what is the null hypothesis in this case? The null hypothesis says that there is no significant effect of remedial classes on the result of students. In other words, we can say there is no significant change in the result of students after remedial classes. Right? An alternative hypothesis says that the result of students is significantly different after remedial classes, or we have significant effect of remedial classes on the result of students. So now go to analyze again. Analyze, compare means, add samples t-test. Click on paired samples t-test. You can see this dialog box. Now we need to tell the SPSS our first variable and second variable, that is the pair. So select external marks and external marks after remedial classes and move them to the variable 1 and variable 2 box. So this is pair 1. Click on options. You can change the confidence interval. So by default it is 95 and therefore level of significance is 0.05. Close it and click on OK. Now let's understand the result. So we have 3 tables: paired sample statistics, paired sample correlations, and paired sample t-test. This is descriptive statistics. So here we have x1 bar and x2 bar. Mean of external marks before remedial classes and after remedial classes. So you can see x1 bar is 43.98 and x2 bar is 50.13. And we are interested to know whether this difference is statistically significant or not. So is it worth to continue remedial classes? This is n, that is standard deviation, sorry, sample size. Then we have standard deviation and standard error of mean. Here we have correlation. And then we have paired samples t-test. So what is mean difference? It is minus 6.150. See the difference, 43.98 minus 50.13. That is minus 6.150. Difference in standard deviation. Right? Then we have T ratio minus 3.632. Degree of freedom is 59, that is n minus 1. And P value is 0.001, which is less than alpha. Now, since P value is less than alpha, we reject H naught. Why we reject H naught? Because P value is less than alpha. So what will be our conclusion? We can conclude that remedial classes have the significant effect on the result of students, or result of students are significantly different after remedial classes. And from mean marks, you can easily say that the result of students have improved, because the mean marks of the class has increased. The mean has increased after remedial classes. Right? Any doubt in paired t-test? Anyone? You can write in the chat box, or you can unmute yourself. Okay, so let's try to perform paired t-test again. Now you change the data of external marks, or give external marks between 40 and 50. Between 40 and 50. And then see whether you have the significant difference or not. So let me change for you. So we will get the same answer.
Sir, screen is not visible.
Oh, sorry. Okay, so 45, 43, 42, 1. Sorry. The Okay, so here we have the data. Now try by yourself to find whether you have the significant difference or not. Write your answer in the chat box. In this case, null hypothesis will be accepted or we fail to reject the null hypothesis. Okay, let me check. Paired samples t-test. Simply click on OK. No, it should be rejected. Say external marks 44 and external marks after remedial class is 50 and SIG value is 0.000. But I think our data files are different. We have not entered the same data. So I just want you to check whether your SIG value is higher than 0.05 or not. If it is higher than 0.05, you reject, you fail to reject. If it is lower than 0.05, you reject the null hypothesis. Okay, okay. Okay, let's understand the independent t-test. Now, independent samples t-test is used to compare the means of two unrelated groups or independent groups or populations on the same continuous variable. So here these two groups are mutually exclusive groups, or there is no overlap between two groups. So it is used to draw conclusions about the means of two populations and used to tell whether or not they are similar. First, we have random collection of sample. Compute sample mean for two unrelated groups, that is x1 bar and x2 bar. 3, compare two sample means with each other. Right? We are using the same symbols, but here these two groups are independent and not same or not paired. The examples. To examine whether consumption expenditure of male and female are significantly different. So consumption expenditure is our quantitative variable and it must be normally distributed. Now here we have two groups, male and female. Now these two groups are mutually exclusive. Right? They are significantly different. And we are interested to know whether the male and female consumption expenditure are significantly different or not. Second, to assess whether depression level of children are different in joint and nuclear families. So depression level is quantitative data. It must be normally distributed. And then we have two groups, children from joint family and children from nuclear family. Now, what do we mean by two independent groups? If you fall in first category, the same observation cannot fall in the second category. That is the idea of independent groups. So therefore, they are these two groups are mutually exclusive groups. Third, examine the effect of violent video games or movies on the level of aggression. So level of aggression is our dependent variable. It must be normally distributed. And then we are interested to know the effect of violent video games. Right? So you can have two independent groups. Fourth, examine the effect of two brands of fertilizers on the level of farm production. So level of farm production is our dependent variable, quantitative variable. It must be normally distributed, and we have two brands of fertilizers. So we have two groups. And three, examine the effectiveness of two different drugs on reducing the high blood pressure level. So high blood pressure level is our dependent variable. Normal distribution is required, and we have two different drugs. So these two are independent groups. So here, if you see carefully, all two groups are mutually exclusive. Mutually exclusive. Right? See hypothesis formulation. How we can formulate null and alternative hypothesis in independent test. Null hypothesis says that there is no significant difference in mean of two unpaired groups. So mu1 is equal to mu2. As I said, we always write null hypothesis for population parameters and not for the sample statistic. An alternative hypothesis, we have the significant difference in the mean of two unpaired or two independent groups. So mu1 is not equal to mu2. The first step, random selection of sample. Second, check normality assumption. Random selection, normality assumption. Define null and alternative hypothesis. Specify level of significance, that is alpha. Calculate sample statistic. And this is the decision rule. If p-value is less than alpha, we reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. Let me share the SPSS data file. I'm closing this and opening the same data file without saving it. So I want the original data back. Yes. Now we are interested to know whether we have significant difference, gender-wise significant difference in internal marks. We are interested to know whether we have gender-wise significant difference in internal marks. So internal marks is our continuous variable. It is normally distributed. And we are interested to know the gender-wise difference. So in gender, we have two categories, male and female. These two are independent groups, and therefore we can use independent samples t-test and not paired samples t-test. Right? So what is null hypothesis here? How can we frame null hypothesis? So H naught no significant difference between male and female internal marks. No significant difference between male and female in terms of internal marks. Right? So mean internal marks of male is equal to mean internal marks of female. And H1 says that we have the significant difference. Right? Let's see how to perform it. Go to analyze again. Compare means independent samples t-test. Again, go to analyze. In analyze, we have the option of compare means. In compare means, we have the option of independent samples t-test. So select independent samples t-test. Select external marks, internal marks, because internal marks is our dependent variable. So move it to the variable test variable box. Now we need to define the grouping variable. Now our grouping variable is gender. So select gender and move it to the grouping variable box. Once you move the variable in this box, you see define groups button is on. Right? So click on define groups. Now we need to tell the SPSS that group 1 is this and group 2 is this. So we have assigned 1 to male and 2 to female. So group 1 is 1 and group 2 is 2. Suppose you have assigned 0 and 1. So instead of 1 here you can write 0 in group 2, 1. Suppose you have assigned 5 and 6. So you can write 5 in group 1 and 6 in group 2. Right? So 1, 2, continue. You can see here gender in bracket 1 and 2 is written. That means we have two groups and these two groups are group 1 and group 2. Because we have assigned 1 to male and 2 to female. Econ options. You can see confidence interval percentage is 95. That is alpha is 0.05. So click on continue. and simply click on OK. Now see the result. This is first table. And that is 30, 30, 30. So we have 30 male students and 30 female students. This is sample mean, that is x1 bar and x2 bar. So you can see x1 bar or mean of male students is 17.73 and mean of female student is 17.87. This is standard deviation and then we have standard error. Now, before we interpret the result of independent sample t-test, we need to check whether variances of these two groups are same or not. So here you see we have the result of 11th test for equality of variances. So when we are dealing with two independent groups, we need to check the variances of these two groups. Right? Normally we assume that in independent t-test that variances of two groups are equal. Right? So what is null hypothesis for this, for 11th t-test? It says that H naught variances are equal, and alternative hypothesis is variances are significantly different. Now this is the F ratio, F statistic for 11th test, and associated p-value is 0.722. So p-value is greater than alpha. If p-value is greater than alpha, we fail to reject H naught, and therefore we are concluding that variances are equal. Right? Again, what is 11th test for equality of variances? It shows whether, or it is used to check whether the variances of two independent groups are equal or not. Right? So null hypothesis says that yes, variances are equal or variances are not significantly different from each other. An alternative hypothesis says that variances are significantly different from each other. They are not same. So p-value, associated p-value is 0.722. It is higher than alpha. Therefore, we fail to reject the null hypothesis. Since we fail to reject the null hypothesis, we are concluding that variances are equal. Now let's understand the add t-test result. So this is t ratio, that is minus 0.096. Degree of freedom is 58. Why it is 58? So it is n1 minus 1 plus n2 minus 1, because we have two different samples. So it is n1 plus n2 minus 2. So it is 60 minus 2, which is equal to 58. Then we have mean difference. It is x1 bar minus x2 bar. So here we have mean 17.73 minus 17.87. Right? And associated p-value is 0.924. Now this associated p-value is higher than alpha, and therefore we fail to reject H0. So we conclude that there is no significant difference between male and female in terms of internal marks, or internal marks of male students are not significantly different from female students. Right? Okay. Now let's do one thing. Give more marks to or give less marks to male students between 5 and 10, and then check what happens. So give internal marks between 5 and 10 to male students. So change your data and try to find out the significant difference, whether we have any significant difference or not. So 5, 7, 9. Nine, 8, 7. So now we have given marks in the range of 5 to 10 to male students, internal marks. And let's see whether we have the significant difference or not. Write your answer in the chat box. I got the answer. Anyone? First check the 11th test, whether we have equal variances or not. Okay, let's perform this. Go to analyze, compare means, independent samples t-test, internal marks is there, group 1 and 2. Simply click on OK. Now you see the difference here. In mean marks, so mean marks for male students is 6.97 and mean marks for female students is 17.87. Right? Now here 11th test is, or F ratio is statistically significant. See p-value associated with the 11th test. Since it is statistically significant, the variances are not equal. It says that variances are not equal. Sorry. Value is less than alpha and therefore variances are not equal. That means we have rejected null hypothesis. H not of 11th test. Right? Okay. Now let's understand the output. The T ratio is minus 10.363. See here. Now we are going to use this row. Equal variance is not assumed. Associated SIG value is 0.000. So here p value is less than alpha for independent samples t-test. Since p value is less than alpha, we reject H naught. And therefore we conclude that we have the significant difference. Internal marks. Gender-wise significant difference in internal marks. And from mean value, we can easily find out that mean marks of female students are significantly higher than the male students. Right? Okay, let's see whether we have the significant difference in external marks. So now instead of internal marks in test variable, move external marks and click on OK. See the result. Here we have 11th test result. And then we have SIG value for t-test. You can see the p-value is higher than 0.05. And therefore we fail to reject the null hypothesis. So we are saying that there is no significant difference. And from mean value, you can see that the mean external marks of male students is 44.50 and mean external marks for female students is 43.47. And this difference is not statistically significant. So we fail to reject null hypothesis. Right, and therefore we don't have any significant difference between male and female students in terms of external marks. And you can also find the difference in total marks. This is the idea of independent samples t-test. Now let's see the comparison. Of these three t-tests: one sample t-test, and a t-test, and independent samples t-test. What is the use? What is the use of one sample t-test? Compare the sample mean with observed population mean, observed value or population mean. And we have only one sample, and therefore it is known as one sample t-test. Then we have paired t-test. Now paired t-test is used to compare the mean of two paired groups. That means two groups are not mutually exclusive, they are correlated. And then we have independent t-test, which is used to compare the mean of two unrelated or unpaired groups. Right? So two groups are mutually exclusive in independent t-test. What is null hypothesis? In one sample t-test, null hypothesis says that there is no significant difference between sample mean and population mean, or in sample mean and observed value or given value. The paired t-test null hypothesis is there is no significant difference between the means of the paired groups. Right? Or two related groups. So it is also known as dependent t-test, dependent samples t-test or dependent t-test. An independent t-test says that there is no significant difference in the means of two unrelated groups or two mutually exclusive groups. Alternative hypothesis. We have the significant difference between sample mean and observed mean in case of one sample t-test. For paired t-test, there is a significant difference between means of two paired groups. And in independent t-test, we have the significant difference in means of two unrelated groups. See the example. Compare the mean marks of economics students with the overall mean marks of the university or overall result of the university. Now, overall result of the university is given value. That is our population mean or observed value. So what is the procedure? You collect the data randomly from the economics department, calculate the sample mean, and then compare the sample mean with overall result of the university and check whether you have the significant difference or not. Then we have paired t-test to compare the mean marks of the students before and after remedial classes. That is what we have done with the hands-on practice. So it basically it is used to know the effect of particular event. So we are collecting the data from the same observation at two different time points, before and after. So effect of remedial classes, effect of any medicine, effect of any drug, effect of exercise, right? So we are collecting data from the same observation at two time points, and therefore we have this pre-post condition or before-after condition. And in independent t-test to compare the mean marks of male and female students, so two groups are completely different, and then we are comparing this. Now make sure you have only two groups in paired and independent t-test. In paired group we have two related groups. In independent group we have two unrelated groups, but groups are two. If you have more than two groups, then t-test cannot be used. We have other tests that we are going to discuss tomorrow. But t-tests are exclusively, paired t-test and independent t-test are exclusively for 2 groups only. If you have more than 2 groups, then you cannot use t-test. For that, we have analysis of variance, ANOVA. So this is the idea of one sample t-test, paired t-test, and independent samples t-test. So if you have any doubts, you can write in the chat box, or you can unmute yourself and ask.
Hello, sir.
Yes.
This is Professor Rahul Gosai, working in the Pune University.
Okay.
Before, I am attempting the different seminar and workshop related to the data analysis and the statistics. But in today's session, you are covering the pair sample t-test, one sample t-test, and independent sample t-test. It is very important for a research student. And in today's session, you are discussing this concept is very effective manner and is very simple and lucid language. So I'm very thankful to you to discuss this concept with very effective and simple manner, as well as this concept will understand to the research students. So I am again thankful to you.
Thank you, sir. Yes, so we have one question here. Now, I had heard null hypothesis must always be rejected, otherwise research is wrong. In one research conference, speaker said this. No, this is completely wrong, because how can you say that your null hypothesis is rejected before you conduct the research or before you conduct the analysis? Normally, the idea is null hypothesis is the claim, right? So it is desired. It is the desire of the researcher that null hypothesis should be rejected, but it is not the rule that it must be rejected. In various cases, you can find various research papers of not rejecting the null hypothesis. Right? So whether you are going to reject the null hypothesis or not, or whether you fail to reject the null hypothesis, that doesn't mean your research is wrong. That is your finding. If your null hypothesis is not rejected, you can say that no, there is no significant difference. What's wrong in that? I hope I've cleared your doubt. Yeah, thank you. Any other questions? Anyone?
Hello, sir.
Yes,
sir. I would like to add to this question that is said by oral, sir. Yes. Actually speaking, they say that you frame your statement in such a way that null hypothesis should be rejected. And we do accordingly, because that is, they say that it should not be accepted. Rejected bhi mat bolo, it should not be accepted. आपको लिखना भी statement वैसे ही है, that null hypothesis cannot be accepted, therefore alternate hypothesis is correct, and therefore so and so. That is what actually from the very beginning we are being taught. Yes. So people have confusion. See, in null hypothesis in general, not for a particular test, in general, null hypothesis says that there is no significant difference between population parameter and sample statistic. Yes. That's it. Or there is no effect, or there is no association. Yeah. So basically, when you do research, normally you are trying to find the effect, you are trying to find the association. That's what, yes. Yes. Yes, any other questions? Participants, if you have other questions, please.
Hello, sir.
Yes, ma'am.
Actually, the downloaded version of SPSS, it shows in following the steps. So I was not able to do all those things, hands-on training.
You have the trial version with you?
Yes, sir.
Okay. And what is the error?
Actually, when we go to analyze the means, so it shows the grids um, it is not showing that variables and all that things. We have to enter the value for the I'm not able to explain it. I have clicked the photo. I can show it through the WhatsApp, but I was trying to send it through the chat, but it is not possible, I guess. Tomorrow.
Okay. So I think if you have any technical assistance, ma'am, Savita ma'am, you can.
Yes, ma'am. You just send the screenshot.
Yeah, I will
on the
show
group.
that in the WhatsApp group. And
Yes,
ma'am,
ma'am.
can
You
we
send it.
please
We'll
get...
connect to sir. That what is the problem? We'll come to know.
Okay, sir. Okay, ma'am. Thank you.
Anyone else? Any other problem? Has someone else tried using SPSS hands-on? Okay, by evening today, we all will try. If at all we all get all such errors, we'll be just posting our errors to sir. आप WhatsApp group पे डाल दीजिए. I'll be transferring it. No problem.
Yeah, no problem, ma'am.
Yes, sir. So I think we can wind up with the session.
Yeah.
Yeah. Shivanjali madam, over to you.
Thank you, Savita ma'am. I, Shivanjali Talari, on behalf of Bharat College of Arts and Commerce, Badlapur, would like to thank Sir for demonstrating the software so easily and so in such a simple way that it was so easy to understand and to do the practice also. I would like to thank the participants for patiently listening and practicing on the same side. Thank you, sir, for gracing this event with your presence. Thank you very much, everyone. Thank you.
Thank you, ma'am.
Thank you, sir. All of you, please put up the fill the feedback form.
Yeah.
And tomorrow, yes, tomorrow we have both sessions training, hands-on training. So all our other doubts will be cleared there.
See, they can try to perform this test, and they have any doubts regarding TDS, they can ask tomorrow also.
Yes, sir. Yes, sir.
Yeah. Thank you, ma'am.
Thank you, sir. So we can sign off, Rushali madam.
Yes, madam.
Yes. Thank you, sir. Tomorrow again we'll continue.
Yeah.